guys, welcome back to my YouTube channel. So today I'm going to explain to you how you should answer the quiz question for the first chapter. So altogether you have 3 different questions, and let's get started with the first question. The first question: in the morning, a paintball pressure tank is at 306 atm. The weather heats up over the course of the day. By 3 p.m., the outside temperature is roasting at 38.5 degrees Celsius, with pressure inside the tank raised up to 324 atm. Approximate what was the temperature in the morning. So for this first question, you should be able to use the formula of P1 over T1 equivalent to P2 over T2, whereby the initial pressure is equivalent to 306 atm and the final pressure is 324 atm, while the final temperature is 38.5 degrees Celsius. So we shall plug in the value. So it shall be 306 for the initial pressure, and the initial temperature is the thing that we want to calculate, and the final pressure is 324, while the temperature is 38.5. So you need to convert this to Kelvin plus 273. So you should get 306 over the initial temperature is equivalent to 324 divided by 311.5. So from here you should get the initial temperature equivalent to 294.1944 Kelvin. Alright, so from here you need to convert back to degrees Celsius, because initially the temperature given to you is in degrees Celsius. So 294.1944 you need to minus 273. So you should get the initial temperature is equivalent to 21.1944 degrees Celsius. So this is the final answer. So how are you going to get 5 marks from this? So this one shall be 1 mark, and then you plug in the value shall be another mark, and then you will get the final the initial temperature 1 mark. You convert it back to degrees Celsius and the final answer. So 1, 2, 3, 4, 5 marks altogether for the first question. Moving on to the second question. Two container A and B, so container A and container B, are joined by the tube of negligible volume as illustrated below. So this is the illustration. The container are filled with ideal gas at pressure of 2.3 times 10 to the power of 5 Pascal. Calculate the total amount of gas in mole contained in the container. So how are you going to do this is that this is a partial pressure question. So first and foremost, because the pressure given to you is in Pascal, so you need to convert this to atm beforehand. And if you can see, the volume of the container is in centimeter cube, so this one also you need to convert it to liter, and also the temperature, I'm sorry about that, the temperature should be converted into Kelvin. So let's get started. According to the question, you have 2 different containers linked together. So you have container A and container B, inside of which they have different type of gases, but the pressure are the same. So you were asked to calculate the total amount of gas. So total amount of gas. So in each container you were given the value of the pressure, and then the volume, and also the temperature. This one is the same as well. So the formula that you can use to tackle this problem is the ideal gas law. PV equivalent to nRT, because the only way for you to know the total amount of gas in mole is this, by using this equation. So we already have converted all the information to the actual unit that we want. So we need to rearrange this formula because you want your nth, right? Therefore, like nRT is equivalent to PV, so your nth is actually equivalent to PV over RT. But because you have two different gases, so what you can do is you need to calculate N1 and N2, right? So total N. So N total is equivalent to N1 PV over RT plus N2 PV over RT. Alright, so now you just need to plug in the value inside this equation. So the value here is the same as the value that we have calculated just now. So the pressure in the question happened to be, it says that in both containers the pressure are the same. So we already converted from Pascal to ATM. Therefore, we will get, so N total shall be 2.2705 times 3.1 over 0.0821 times the initial temperature is 17, right? This one, the temperature here is 17, so you need to convert it to 273. So remember, okay, because 0.0821 is a constant value and the unit for this one is actually in liter, atmosphere, mole and Kelvin. So you need to make sure that the pressure, the temperature and the volume are in the correct unit. So you need to add with the N2, so I'm going to write here, so plus 2.2705 times 4.6 over 0.0821 times 30 plus 273, because you need to convert it to Kelvin. So you should be able to get 0.2956 plus 0.4198 equivalent to 0.7154. So this is the final answer. The final question for your quiz 1. A 40-liter balloon is filled with air at sea level 180 m and 25 degrees Celsius. It is tied to a rock and thrown in a cold body of water, and it sinks to the point where the temperature and the pressure are 4 degrees Celsius and 11 atm respectively. Determine the new volume of the balloon. So actually question number 1 and question number 3 use the same formula, which is the combined gas law. So all you need to do is you need to plug in the formula P1 V1 over T1 equivalent to P2 V2 over T2. Right, so given to you the volume is already in liter and the pressure is in atm, only that the temperature is given in degrees Celsius. So just plug in the value times 40, but the temperature at first it is 25 degrees Celsius, so 25 plus 273, because you need to convert it to Kelvin, and then equivalent to the final pressure is 11 atm, and B2 is the thing that you want to calculate, and it states that the final temperature is 4 degrees Celsius, so 4 plus 273, so you should get V2 equivalent to 11080 divided by 3278. So you should get V2 equivalent to 3.3801 here. Okay, so how are you going to get the total of 4 marks for these questions? That you use the correct formula and then you plug in the correct value and you show the calculation, and lastly the final answer. So bear in mind, for your final answer I would need you to give me 4 decimal points, and if you don't get the accurate value as mine, so marks might be deducted as well. So yeah, so that's all for the first quiz. I hope all of you did well. So see you again in the next lecture. So all the best and see you soon. Goodbye.